In this video, I'm going to solve a few limits using L'Hopital's rule. So there are a few indeterminate forms like 0 over 0, infinity over infinity, 1 to infinity, 0 to infinity, and infinity to 0 that we have to use some methods to not leave the operation like that, to get something, even a finite number or infinity. So let's look at the first problem. Limit as x is approaching 0 of sine to the second of 3x over 5x squared. The first thing that we want to do is to plug in x equals whatever limit we have. So in this case, x equals 0. Plug it in the numerator and then in the denominator. And we are going to get 0 over 0. So basically, we are going to solve the first type of indeterminate form. Now, when we get 0 over 0, we apply L'Hopital, and I write under the equal sign of L apostrophe H to show that we are using L'Hopital, which means we are going to differentiate the numerator, sine squared of 3x prime, over, and we differentiate the denominator. So we don't use quotient rule, we just differentiate them individually. So we get limit as x is approaching 0. The numerator is 2 sine of 3x times cosine of 3x times 3x prime, which is 3. So I differentiated the numerator using chain rule. And the denominator is 10x. Now, if we plug in x again, we get again 0 over 0. So I'm going to differentiate one more time. But before I do that, I'm just going to make it a little bit nicer. So the denominator is 10x. But I remember from trigonometry that 2 sine of 3x times cosine of 3x, it's actually sine of 6x. It's actually 2 sine of x cosine of x. It's sine of 2x. So because the argument is 3x, it's double that, so sine x. And then it's times 3, so I'm going to put the 3 in front. So again, we have 0 over 0, so we apply L'Hopital one more time. So we get limit as x is approaching 0. We differentiate the numerator, which is 3 times cosine of 6x times 6, and we differentiate the denominator, which is 10. Now when we plug in 0, cosine of 0 is 1, so we get 18 at the numerator, 10 at the denominator, which is 9 over 5. So we did the first problem. Let's take a look at the second problem. The second problem, we have x is approaching infinity of ln of 4x plus 3 over ln of 2x minus 1 plus 1. If we plug in x with infinity, we get ln of infinity, and if we make a quick graph of ln, as x is approaching infinity, the function is approaching infinity. So that's why we get infinity over infinity, and again we can apply L'Hopital directly. So limit as x is approaching infinity, the numerator prime, it's 1 over 4x plus 3 times 4x plus 3 prime, which is just 4, over the denominator prime, it's 1 over 2x minus 1 times 2, and then 1 prime is 0. So this one gives us equal to limit as x is approaching infinity of 4 over 4x plus 3 times, right, I have this division, so I would divide by this fraction, which means times, and I flip the fraction, 2x minus 1 over 2. This cancels with this one, but when we plug in, we still get infinity over infinity. So we don't stop here, we apply L'Hopital one more time. So limit as x is approaching infinity of, now the numerator, it's 4x minus 2, prime gives us just 4. The denominator, it's 4x plus 3, prime, it's 4. So the final answer is 1. Let's take a look at another problem. Well, this time we have limit as x is approaching 0 of 1 minus 2x to 9 over x. If we plug in x we equal 0, we get 1 to infinity. So let's put 0 plus just to make sure that the numerator is infinity and not a negative infinity. Now, how do we solve this one? Well, this time I cannot apply L'Hopital right away, so I'm going to use a property that says if I have f to g, I can write as base e in this form, e to ln of f to g, which means e to g ln f. So this is an important change of exponents. Instead of having the base f, or whatever number or function, I have base e. So in our case, it's going to be limit as x is approaching 0 plus of e to 9 over x ln of 1 minus 2x, where I used as my f, right, our f, it's actually 1 minus 2x, and our g is 9 minus x. This g is 9 minus x. So if we take a look at the, they work exactly like that. The g is the blue one and the yellow one. So now, this is going to give me e to some power. So let's calculate the power separately. Limit as x is approaching 0 plus of ln, or 9 ln of 1 minus 2x over x. So if we plug in x with 0, we get 0 over 0, which we can apply L'Hopital right away. So we get limit as x is approaching 0 plus. The numerator prime is 9 times 1 over 1 minus 2x times 1 minus 2x prime, which is negative 2, over the denominator is just 1. So now if we plug in x with 0, we get negative 18 over 1 minus 2 times 0, which gives us negative 18. So the exponent is, or the final answer is e to negative 18. Let's take a look at another problem. We have x to x. So again, we have 0 to 0. We cannot apply L'Hopital right away, so I'm going to use the same writing the base e. So we get e to x ln of x, which is e to some power. So I'm going to calculate the limit separately. Limit as x is approaching 0 plus of x ln of x. Now if we replace x with 0, we get 0 times. Now if x is approaching 0 of this function, the value of the function is approaching negative infinity. So we have 0 times negative infinity, which again, I cannot apply L'Hopital right away, because we apply L'Hopital right away only for 0 over 0 and infinity over infinity. So I'm going to rewrite it in this format. I'm going to put ln of x over 1 over x, because this x here can be written over 1 over x. So now, if we plug in x with 0, we get negative infinity over infinity, so we can apply L'Hopital right away. Limit as x is approaching 0 plus, the numerator prime it's 1 over x, the denominator prime is negative 1 over x squared. So as you can notice, I am not differentiating quotient rule, I'm differentiating each of them. 1 over x prime, ln of x prime is 1 over x, 1 over x prime is negative 1 over x squared. So here I'm going to simplify it a bit. Limit as x is approaching 0 plus of 1 over x times negative x squared over 1. Cancel this and plug in 0, so we get 0. So the final answer is e to 0, which is 1. Now let's take a look at another situation. Limit as x is approaching 0 of x to 1 over x. If we plug in x with 0, we get 0 to infinity. So, again, let's rewrite this using base e. So limit as x is approaching 0 of e to 1 over x ln of x. So again, let's put e and let's calculate the limit separately. Limit as x is approaching 0 of 1 over x ln of x. I can rewrite this in this format. Limit as x is approaching 0 of ln of x over x. If we plug in x with 0, we get negative infinity over 0, which is not, we cannot use L'Hopital. So maybe a better idea would have been to actually put limit as x is approaching 0 of 1 over x, to leave it the way it was before. And when we plug in x with 0, we get infinity times negative infinity, right? So we get negative infinity squared. Now, let me actually make sure we are clear on what sign we have. So I'm going to put plus here, x is approaching 0 plus, because now when x is approaching 0 plus, this quantity is going to approach positive infinity, like I wrote here, and x is approaching negative infinity. So yes, we do get negative infinity squared, which is negative infinity. So when we go back here, we have e to negative infinity, which is actually 0. Why? Because e to negative n, it's 1 over e to n. So in our case, it's going to be e to infinity at the denominator, which is infinity, so then we get 0. Let's take a look at another situation. Limit as x is approaching infinity of 5x to 3 over x. We plug in x with infinity, we get infinity to 0. So I'm going to use again limit as x is approaching infinity, e to 3 over x ln of 5x. So I'm going to calculate, I put e and then I leave some space where I'm going to put the answer. So limit as x is approaching infinity of 3 over x ln of 5x. Well, this time would be a good idea to actually put them together, 3 ln of 5x over x. So we get infinity over infinity, which we can apply L'Hopital. Limit as x is approaching infinity of 3 times ln of 5x, it's 1 over prime, it's 1 over 5x times 5x prime, which is 5, over 1. So when we plug in infinity, we get 3 over infinity, which is 0. So we go back, e to 0, it's 1. Don't forget once you stop at e to put back the answer. And then there is another situation. If we have to calculate this problem, I want to solve this using 2 methods. Method 1 is basically at the beginnings of calculating limits. I can say that this limit is actually equal to 1 over negative 5 because the degree of the numerator equals the degree of the denominator. So we just take a look at this and this, so then we are getting that. This is equivalent of factoring out x to the third from the top and getting 1 plus 2 over x plus 4 over x to the third over factoring out x to the third from the denominator and getting 7 over x squared here. These two cancel. Now, as x is approaching infinity, this is 0, this is 0, this is 0. So we end up with negative 1 over 5. These two methods are equivalent. Now another method, method 2, would be L'Hopital, because if we plug in infinity, we actually get infinity over infinity or infinity over negative infinity, which means we can apply L'Hopital. So basically, the limit of x is approaching infinity of, if we differentiate the numerator, we get 3x squared plus 4x. If we differentiate the denominator, we get negative 15x squared minus 7. We plug in again, we get infinity over infinity, so again we apply L'Hopital. Limit as x is approaching infinity of 6x plus 4 over negative 30x. Again, if we plug in, we get infinity over negative infinity, but we still apply L'Hopital, so we differentiate the top, we get 6, we differentiate the bottom, we get negative 30, so we can simplify and get negative 1 over 5, which was the same thing that we got before. I hope this helps.